Hello, Year 7. So before we make a start on the actual lesson, which will be one of the first lessons to cover the topic of space, I've got three questions that I would like you to try first. Do it now questions. So pause the video and have a go at question number 1 and number 2. And if you want to try the challenge question, you can do that as well. So how did you get on with those do it now questions? So the question number 1, the answer to our solar system lying in the Milky Way. What do you think the Milky Way is? Well, it is indeed a galaxy, and a galaxy is a huge collection of gas, dust, and billions of stars and their solar systems, including ours, of course, our sun and our solar system, all held together by gravity. Okay, now I've sort of answered question number 2 as well within my explanation of what a galaxy is. There are billions of stars in the Milky Way galaxy. Now, in terms of the challenge, when you look up at the night sky, you see lots of dots of light that don't appear to move. I asked you to list what the dots of light could be. Well, they could be stars. They can actually be entire galaxies. And they could be planets. We can actually see 5 of the 8 planets in our solar system with our naked eye. This unit is about space, and we're starting with P4.2. This P4.2 is taken from the Activate 1 book, so you can follow the course of these lessons using your Activate 1 book as well. And we're starting with P4.2, the solar system. Your learning objectives for this lesson are to name the objects in the solar system, to describe some similarities and differences between the planets in the solar system, and to describe how our solar system might have been formed. So, our solar system. The word solar means sun, and our solar system consists of 8 planets, 4 inner planets and 4 outer planets, and they are circling or orbiting the sun. The sun is a star, and the way that they orbit or circle the sun is in a squashed sort of circle, which is called an ellipse, in between Mars and Jupiter. As you can see on the diagram as well, we have something called an asteroid belt, and it is the sun's gravity that keeps the planets in orbit. Mercury is the smallest planet, and it can actually be seen from Earth with just our eyes. It's a very, very rocky planet. Venus is also a rocky planet, and it is the hottest planet of all. Even though it's further away from the sun than Mercury, it's actually a lot hotter than Mercury. And this is because the atmosphere of Venus contains carbon dioxide, and this carbon dioxide gas helps to trap the heat and therefore raise the temperature to figures which are much higher than Mercury. Jupiter is our biggest planet, and it can actually also be seen with just our eyes. It has 67 moons which orbit Jupiter itself. Then you've got Saturn, which is also a planet that we can see with our eyes, and this has over 60 moons as well, and it has those beautiful rings as well that you can see around the outside of the planet. They look solid, but they're actually just made out of gas. So, a bit about the planets themselves. There are, as we say, 8 planets. 4 are the inner planets. That's Mercury, Venus, Earth, and Mars. They're quite small compared to the outer planets, which are Jupiter, Saturn, Uranus, and Neptune. Now, the name given to the 4 inner planets is terrestrial. So they're called the terrestrial planets, and they're made from rock. On the other hand, the 4 outer planets are made from gas. The gas is usually hydrogen or helium, although if you look at the case of Uranus and Neptune, they are also containing a lot of methane gas. And if you want to remember the order in which these planets are positioned from the sun, you can use a mnemonic. My very easy method just speeds up naming. So my, M for Mercury, very, V for Venus, easy, D for Earth, method, M for Mars, J just, J for Jupiter, speeds, S for Saturn, up, U for Uranus, and naming N for Neptune. In between Mars and Jupiter, we can find most of the asteroids in our solar system. They are in a place called the Asteroid Belt, and they are also orbiting the sun. There are millions of them. Some of them are just the size of very, very small boulders, and the largest of all is an asteroid called Ceres, and it's actually known as a dwarf planet, and I will talk to you about what a dwarf planet is in the next slide. And they're generally made of metals and other rocky objects. Outside of our solar system, there is a region called the Kuiper Belt. This region is much bigger than the asteroid belt, and this is where Pluto can be found. Now, Pluto used to be considered the ninth planet of the solar system, but about 16 years ago, it was discovered that there were a lot of larger objects very, very close to Pluto. And so Pluto was no longer considered a planet in the solar system, but it was called a dwarf planet. And a dwarf planet is a planet that has a gravitational force field that is not strong enough to clear their own neighborhood, like other planets are able to do. So there may be other objects in its orbit around the sun. And some of these other objects, as I said, are even bigger than Pluto itself. So it was no longer considered a planet, but a dwarf planet, a bit like Ceres, the largest asteroid in the asteroid belt. Now, beyond the Kuiper Belt, there is the furthest region known to us, just outside our solar system, which is called the Oort cloud. And this is where it's thought that the comets originate from. Comets are a bit like asteroids, but they're not only made of rocky material, but they're also made of dust and ice. And some comets, they follow a regular orbit around the sun. But if the comet is pulled into an orbit which carries it a little bit closer to the sun, then what actually happens is that the solar heat from the sun causes the comet to start to vaporize, and it becomes a gas and produces a very, very distinctive and actually quite beautiful tail. So, how was our solar system allegedly formed? Well, it's estimated that it was formed about 4.6 billion years ago from a dense cloud of gas and dust. The cloud collapsed, possibly due to the shock wave of a nearby exploding star called a supernova. When this dust cloud collapsed, it formed a nebula, which is like a spinning, swirling disk of material. At the center of this nebula, gravity pulled more and more material inwards. Eventually, the pressure in the core, or the center, was so great that hydrogen atoms began to combine and form helium, releasing a huge amount of energy. And with that, our sun was born. And it pretty much amassed more than 99% of all of the available amount of stuff around it. The remaining 1% of matter, or stuff that was left over out in the disk, was basically also clumped together. These clumps smashed into one another, forming larger and larger objects. Some of them grew big enough for their gravity to shape them into spheres, becoming planets. Others formed dwarf planets, and some of them formed large moons. And that's essentially how our solar system came into existence.